All right, hello. Whatchamacallit? We are back. Doing another problem, maximum frequency stack. I think this is the last. What do you call it? Uh, top K problem or like top K coding strategy, whatever problem. Um, so yeah. Don't know what else to say. I guess we can get back into it. Actually, before that, I just got the new keyboard. It is reasonably louder than before. If you think it's too loud, I think I can try to lower my microphone like input gain and then just try to talk louder and hopefully it doesn't register as much. Um, at least in the start of the video when I start typing, I'll try to what do you call it? Monitor the microphone like levels to see if like the keyboard gets picked up a lot. I realized the last one got picked up. I think it was just a little bit, like some, but like since this is significantly louder, um, I'll try to I'll try to keep an eye on it. If it is too loud, I think I can try to make some modifications, but hopefully it isn't. But yeah, let's just get right into this. Design a stack like data structure to push elements to the stack and pop the most frequent element from the stack. Implement the frequent stack class. Frequent stack constructs an empty frequency stack. Void push integer val pushes an integer val onto the top of the stack. Int pop removes and returns the most frequent element in the stack. If there is a tie for the most frequent element, the element closest to the stack's top is removed and returned. So, yeah. Um, I guess it really just depends on uh basically whatever we how do I explain this? Um yeah, so basically it's just a stack, but then it's a max heap mixed in with a stack, right? I don't know how else to really explain it. Um so I guess we can look at the example. So, um with the example, we start by pushing things on 5 7 whatever. So this is the stack, right? So we pop off the most frequent, which is 5 because there's three of them. Uh, and so we pop off the 5, and then we're left with this basically, right? And then actually it shows you right here. Stack becomes this, and then since 5 and 7 are the most frequent, but 7 is closer to the top because it's like this is the top, right? The 4 right here. So we pop off the 7, and then we pop off the 5 because then 5 is now the closest. Now 4 is closest to the top, so then we just pop off like that. So basically we pop off essentially as by max heap, but then we also pop off by um I guess frequency, like as our tiebreaker. So here we're going to be implementing a class called element. Um and so what we want to do here is create, I guess, an element in the sense that will be able to be sorted in the max heap. Um, and then that way it will, I guess, how do I explain this? Um, Order itself within the max heap, right? And I also forgot we want to from heap q import star. Um, I might have mentioned this before. Let me close my window. Okay, because it was kind of loud outside. Might have mentioned this before. You maybe don't want to do this actually in an interview because you want to show that you're actually using something from HeapQ. But then I'm just trying to save myself my brain cells, so I'm going to not do that. Um, so yeah, let's get into implementing this class element. So we're going to be implementing the init function, which is used whenever we try to create what do you call it? An instance of the object. So we'll be initializing the number, the frequency, and the sequence. So we'll just do self.number is equal to number. Actually, let's shorten this a little bit because kind of don't want to type all that much. Self.number, oh whoops, that's the right arrow key. Self.frequency is equal to frequency, and self.sequence is equal to sequence. Yeah. So after that, we're going to be defining the less than function, and then we compare to the other. And so basically, if self.frequency does not equal to other.frequency, then you want to do return self.frequency is less than, okay. It's other.frequency, but the reason why I was going to do less than because, this is a less than, but the reason why you actually want to return greater than because we're using heap queue, which is implemented as a min heap, right? But since it's a min heap, we need to essentially manipulate it so that it keeps its properties as a min heap, but then we're just essentially inverting our less than so that we make it into a max heap, if that makes sense. It's like the same practice as like if we have this, like we can create so let's just say we have this array of -1, -2, -3, right? And so a min heap would organize this into -3, -2, -1. Whoops, I am missing keys here. So basically this is what our min heap would look like, right? Because the smallest number is on top. So since we're essentially manipulating the heap queue into being that, we want the technically the smaller values on top. Okay, yeah, they're technically smaller values, but then it's because we're manipulating it so that it's actually a smaller value, even though it's a max heap, if that makes sense. So it's if you remember any of the questions, it's like the reason why we push, like we do like a heap push onto max heap of like negative value and the key. I think, yeah, we used that in the scheduling task problem yesterday. So like this makes it into a max heap, but like it keeps the min heap properties of heap queue because it does make the smallest value on the top, but then like it's only because we're manipulating it that way, right? And so here we're making it return that self.frequency is greater than. So we're doing the same thing here, right? It's like it's almost as if we're negating both of these and returning which one's less than. But like you can just make it greater than, and then it works the same way because if you negate everything, like that's how like the logic works, right? I think you learn that with like Boolean math? What, discrete math? Something whatever like that. If you don't go to school for CS, maybe that's like that's something that like you never heard of, but discrete math is something that you can learn and probably should, right? As a developer, if you do want to like develop things, it can make your logic essentially not as complex if you understand how like the Boolean logic works, right? And then so if the frequencies are exactly the same, then you want to return self.sequence. You want return self.sequence is greater than other.sequence. So the reason why we're still doing greater than is because we want to do this inadvertent max heap type of thing. So that's why you want to do greater than as opposed to less than, right? And now we have this class element. So with the class element, that's what we'll be pushing onto our frequency stack, right? So we're going to have here self.sequence number is equal to 0. So this will give us like what is it? Whatever is closest to the top, right? And then so this is the same thing. If the number is greater, then we'll be closer to the top because we're implementing it as a min heap, right? Or like, it's a min heap, but we're trying to manipulate it. So the greater the number, it will be closer to the top if the frequencies are exactly the same, right? We're going to be creating a max heap, which is just an array, and we're going to do a frequency map, which is just an empty map. And the reason for this is this is how we can keep track of the frequency, and with the frequency we will be able to order it in the max heap, right? So whenever we push a value, we need to create what do you call it? We need to update the value. We need to update the frequency, and then we need to create an element, and then we'll push it onto our max heap, right? So first we're gonna need self.frequency map. The val is equal to self.frequency map dot get value or 0, because it's possible that it's not in the map yet. So we need to return 0 plus 1. Now we need to create an element, right? So we need to do heap push okay, actually I guess it doesn't really matter for the sequence number. You can start from 0, or you can make it 1 base indexing. I was just thinking whether or not I wanted to make it 1 base indexing or not, but yeah, you know what, here. So I guess the sequence will just be however many numbers we've seen so far, but it works exactly the same way. You can do it without it as well. So you'll do heap push onto the self.max heap, right? You're pushing a new element which consists of the value self.frequency map.value and self.sequence number, right? And then here you're going to do self.sequence number plus equals 1, and then the sequence number will just keep increasing for the number of numbers that we've pushed in so far. You can also do 0. I don't think it really matters. Yeah, it doesn't really matter. It's just off by 1. But I guess in a sense, you can just see how many numbers you put on with this. Actually, no. With 0, it would actually be the number of numbers that you put on. Yeah, so either way, I mean, it still gives you the same result, 0 or 1. Doesn't actually change anything about the code at all. So yeah, now we've successfully pushed onto our heap, and now so you would just you're just going to be popping stuff off of the heap, right? The max heap, and then you'll just also be decreasing the number of frequencies in our map. So you do number is equal to heap pop off self.max heap, and then if what is it? Self.frequency map number. Since we're popping it off, we know guaranteed for sure there's at least 1, right? If it's equal to 1, oh no, sorry. If it's greater than 1, then you'll just do self.frequency map number minus equals 1, else you'll do delete self.frequency map number, right? So basically, if it's at least greater than 1, then we'll take it down to 1 or higher. But if it's equal 1, which is like the only possibility, because we basically start from 1, right? Since we always return 0 plus 1, like at least minimum 0 plus 1. But if we're at 1, then we get to 0, and if it's 0, then we can just delete it from the map. deleting it isn't, oh, whoops, I didn't put a colon there. Deleting it isn't necessarily necessary. Okay, that sounds kind of funny. It isn't necessary. It's just, theoretically speaking, if this code were to keep running forever, and you keep eventually taking numbers to 0 and not deleting it, your frequency map will take up a lot of space just to have a number and 0. So that won't be really effective. But I mean, in an interview case, the numbers that you'll get are probably not that much, so it won't be affecting it that much. But I think it's a better practice just to delete it anyways, and then we'll return the number at the very end because we popped it off. So yeah, with that being said, I think everything looks good. You initialize everything and then you sort it with this. And then you have the sequence number, your max heap, your frequency map. You get how many times it's in, like the frequency of the thing. You push it onto the max heap, increase sequence number. You never decrease sequence number because you might end up having conflicting ones and you don't have any cases to, like, you know, change that. So you never decrease sequence, and then you pop it off and you decrease the frequency and you return the number. Yeah, so it looks about right. Oh, wait, what? Self.frequency map num is equal to heap pop. Oh, okay, wait. Forgot to do, you want to get the number. Whoops. Actually, we'll do number here, actually. Because, okay, the reason why this didn't work, whoops, probably kind of forgot about this part, is because we're popping off an element, right? An instance of element, and you can't, we're looking for like an integer, right? Not an instance of element in our frequency map. So that's why there's a runtime error. We only care about the number here, and we can decrease the frequency here, and that would be it. There we go. Okay. Whew. You know, missed a little tiny part, but you know, that is how you do this maximum frequency problem. And yeah, hopefully the keyboard wasn't too loud, but yeah, that's it for me, and thanks for watching.